Good morning, friend. Today I will give brief idea about the BJT transistor. BJT means bipolar junction transistor. Why its name is bipolar? Because in BJT the current flow due to the both electrons and holes. So electron and holes are different polarity. That's why its name is bipolar. Means current flow due to the both electrons and holes. Junction. Because we know in BJT there are two types of junction, emitter base and base collector. That's why its name is junction. Transistor. Transfer resistor means it converts either low impedance to high impedance or high impedance to low impedance, means transfer resistor, transistor. Now application of the transistor or application of the BJT transistor. Mainly there are two types of application. First is as an amplifier and second as an electronic switch. As an electronic switch application is used in the digital electronics. So first is as an amplifier to operate transistor. As an amplifier, the BJT must be in active region, and to operate transistor as an electronic switch, BJT must be in either saturation region or cutoff region. If the BJT in the saturation region, then it is on, and if it is cutoff region, then it is off. So in this way, it acts as a switch on off. In saturation region, it is on. In cutoff region, it is off. Second, types of transistor. Mainly, there are two types of transistor: NPN transistors and PNP transistor. This is the block diagram of the NPN transistor. So emitter is N type, base is P type, and collector is N type. We see that here. In the emitter base is the forward bias and base collector is the reverse bias. And we know in forward bias impedance is low and in reverse bias impedance is high. So this transistor converts. So input port is at the low impedance and output port at the high impedance. So it converts low impedance to the high impedance. That's why its name is transistor, transfer resistor. Second is the PNP type transistor. In this case, emitter is P type, base is N type, and collector is P type. In NPN transistor, current is due to the mainly electrons, and in PNP transistor, current is due to the holes. In practical, NPN type transistor is more popular than the PNP transistor. Why? So we know that in NPN transistor, current is mainly due to the electrons, and in PNP transistor, current is mainly due to the holes. And we know that mobility of the electrons is more in comparison to the mobility of the holes. So that's why NPN transistor is more popular than PNP transistor. Now the symbols of the NPN transistor and the PNP transistor. So this is the symbols of NPN transistor. In this case, direction of the current at the emitter terminal is outward in NPN transistor, and in PNP transistor, direction of the current at the emitter terminal is inward. And in both cases, the relation between emitter current, base current, and collector current is same. Emitter current is equal to sum of the base current and the collector current. Now the construction of the transistor. In construction of the transistor, we will mainly focus the two parameters. First is the size of the transistor, and second is the doping level of the terminal. So size of the transistor, size of the emitter, base and collector, and also doping level of the emitter, base and collector. So in this case, size of the emitter is moderate and doping level is highest. For base, size is thinnest and doping level is least doped. For the collector terminal, size is largest and doping level is moderate. So from this table we can conclude that base has the least area and the least doping level. Collector has the largest area and moderate doping level. Emitter has the highest doping level and moderate area. Why we consider such types of parameter? It is used to improve the efficiency of the transistor. We will discuss in the next slide why such parameter is taken. It is used to improve the efficiency of transistor. So first, current in the transistors. There are three types of current: emitter current, base current, and collector current. Emitter current is denoted by IE, base current is denoted by IB, and collector current is denoted by IC. Now next, emitter current. This is the emitter current. See, emitter and base junction is the forward bias. So, electron will be moved from end emitter to the base terminal, and hole will be moved from base terminal to the emitter terminal. And from diagram it is clear that flux of the electron is more in comparison to the flux of holes. So emitter current is mainly due to the flow of electrons from emitter terminal to the base terminal. So emitter current IE is equal to electron current due to the electrons plus current due to the holes. So emitter current IE due to the flow of electrons. Most useful current due to the electron is the useful current, and current due to the hole is not useful current. So it is the current due to the electrons is useful, so it can be increased by the heavily doped of the emitter terminal. That's why emitter is heavily doped. Why it is heavily doped? If the emitter is heavily doped, then the current due to the electrons is more, and efficiency of the emitter terminal will be improved. Now IH is due to the flow of holes. It is not useful. It is decreased by the lightly doping of the base terminal. So in the construction we see that emitter is heavily doped and base is lightly doped. So if the emitter is heavily doped, then the current due to the electrons is more and current due to the holes is less. So if the current due to the electrons is more and current due to the holes is less, then efficiency of the transistor will be increased, or efficiency of the emitter terminal will be increased. Efficiency of the emitter terminal. Efficiency of the emitter terminal is defined as the ratio of the current due to the electrons to total emitter current. Means current due to the electrons plus current due to the holes. Now, efficiency of the emitter terminal can be improved by base lightly doped. What happens if the base is lightly doped? If the base is lightly doped, then the current due to the holes is less, and emitter is heavily doped. What happens if the emitter is heavily doped? Then the current due to the electrons is more. So if the current due to the holes is less and current due to the electrons is more, then efficiency of the emitter terminal will be improved. Now base current. Base current is denoted by the IB. This is the diagram of the base current. From the diagram it is clear that base current is mainly due to the small diffusion of the holes and recombination of electrons and holes in the base region. So IB is the combination of recombination current plus hole diffusion current. Base current is largely recombination current, means base current is the both recombination of the electrons and holes in the base region plus the hole diffusion, but dominating part is the recombination current in the base current. Efficiency of the base terminal. Efficiency of the base terminal is defined as the electron reaching at the collector terminal to total electrons reaching at base terminal. We know base acts as an intermediate between the emitter terminal and the collector terminal. It transmits the electrons from emitter terminal to the collector terminal. So if the doping level of the emitter terminal is base terminal is low, then the more electron will be transmitted from emitter terminal to the collector terminal, and recombination of electron and hole in the base region is less. If the base is highly doped, then the recombination of electrons and holes will be more in the base region, and number of electrons reaching at collector terminal is less. That's why base is lightly doped. In construction, we see that base is lightly doped. If the base is lightly doped, then the more number of electrons will be reached at the collector terminal, and efficiency of the base terminal will be increased, and overall efficiency of the transistor will be increased. So, as the thinnest and doping of the base terminal is less, recombination of electrons and the holes are less in the base region, and more electron will be reached at the collector terminal. So, efficiency of the base terminal will be improved. Now, second, BJT is minority operated device. Why BJT is minority operated device? Because in NPN transistor, operation of the BJT depends upon the flow of electrons from emitter terminal to the collector terminal. If more number of electrons reaching at collector terminal, efficiency of the BJT is more, and emitter and electron in base region is minority in nature. That's why BJT is the minority operated device. Now, second is the collector current. Collector current defined as the current due to the flow of electrons reaching from emitter terminal to the collector terminal. So, if the electron will be transmitted from emitter terminal to the collector terminal, then some electron will be recombined. So, the collector terminal is defined as the alpha times emitter current plus ICVO. Alpha is the current gain and ICV measure this component of it when the emitter terminal is open. Emitter terminal is open means emitter base is the unbiased. So value of alpha depends upon the recombination of electrons and holes. If the recombination is more, then the value of alpha is less. And if the recombination is less, value of alpha is more, and gain of the current will be more. So, collector efficiency. Collector efficiency is defined as the number of electrons collected by the collector terminal to the number of electrons arriving at the collector terminal. So, if the area of the collector terminal is large, so more electron will be collected by the collector terminal, and efficiency of the collector terminal will be improved. That's why in construction, area of the collector terminal is largest. As the size of the collector is large, efficiency of the collector terminal will be improved. So this is the three types of current in the BJT: emitter current, base current, and collector current. And we design the transistor or dope the transistor in such a way that efficiency of the emitter terminal, base terminal, and collector terminal is high. If the efficiency of the base terminal, emitter terminal, and collector terminal is high, then overall efficiency of the transistor is more. We will discuss next topic in the next video. Thank you.